Good day, viewers. Welcome to the Physics Mind. Today, we will be looking at friction and specifically the coefficients of friction. In our last video, we have explained the concept of friction, the types, the advantages, disadvantages, and ways of reducing friction. If you have not seen that, please go back and check the last video. Okay, so coefficient of friction. For us to look at the coefficient of friction, let us consider a body that is sliding on a rough horizontal surface, just like what we have on the board. Now, this is our rough horizontal surface, and let's consider a block of wood. This is a block of wood. Okay, so it's resting on this rough horizontal surface. Okay, so for this wood, we know that the entire weight of this wood is acting downward. That is the weight of the wood. And also, let's consider that this wood is being pulled in this direction. Let's say this is the direction of the motion. Okay, if this is the direction of motion, and then of course we know that friction is a force that opposes motion. So the direction of friction will be opposite to that of what? Direction of motion. So friction will of course act in this what? Direction. So we write it. This is our direction of frictional force. And lastly, now since the body is resting on a horizontal surface and the weight is acting downward, and from Newton's third law of motion, we know that what? Actions and reactions are equal and opposite. So the ground will also react back on the wood, but in an upward direction. So we consider this to be the what? The normal reaction of the ground back on the wood. Okay, so this is just a diagram to illustrate how we can obtain our coefficient of friction. Okay, so experiments have shown that the normal reaction of the ground on the wood is directly proportional to the what? The frictional force. Okay, so just like we said, the frictional force varies directly proportional with the normal reaction. So we can write that mathematically as frictional force is directly proportional to the normal reaction. So this is a normal reaction. F is the what? The frictional force. So from mathematics, we know that if your proportionality sign changes to equality sign, you always have a constant, and we call that constant mu, and multiply by what? By r. So where mu here is a constant of proportionality, which is called the coefficient of friction. So we will make mu subject to the formula. Mu will now be equal to the frictional force over the normal reaction. So this gives us an equation for the what? The coefficient of what? Friction. So we can write that mu is the coefficient of friction, and our F is the frictional force, and our R is equal to the what? The normal reaction. Okay, so one important thing we need to know is that for a body resting on a horizontal surface, the normal reaction is always equal to the what? The weight of the body. So we are saying that normal reaction is equal to the weight of the body, and the weight of the body is equal to the product of the mass times the gravity, and mass is what must be measured in kg, while g is the acceleration due to gravity, and it must be in meter per second squared. So always take note that your normal reaction is always equal to your weight of the body. So that gives us the normal reaction and also the weight, and lastly the coefficient of friction. So let's look at examples on how we can use this equation to solve problems. A wooden block of mass 1.6 kg rests on a rough horizontal surface. If the limiting frictional force between the block and the surface is 8 Newton, calculate the coefficient of friction. And acceleration due to gravity G is 10 meters per second square. And this is actually a wide question, 2000. Okay, so for us to solve this question, let us first of all bring out our parameters. So we'll bring our parameters that will guide us on the right equation or formula to use. Okay, so we are told that a wooden block of mass 1.6 kg, that is the mass of the block. So let's call it M, and is 1.6 kg. And it rests on a rough horizontal surface. And we are told that if the limiting frictional force between the surface is 8 Newton. So this 8 Newton, that is the frictional force. So let's call it F. Frictional force is 8 Newton. Okay, so we are asked to calculate the coefficient of friction. So coefficient of friction, that is mu. So we are looking for the coefficient of friction. And we are given G, acceleration due to gravity, to be 10 meters per second square. Okay, so how do we get our coefficient of friction, mu? So we know that our coefficient of friction, mu, is equal to our frictional force over the normal reaction. Okay, so we have our frictional force, but we don't have our normal reaction. So we need to find our normal reaction. So how do we get our normal reaction first? Recall that your normal reaction is equal to the weight of the body. And the weight of the body is the product of the mass times acceleration due to gravity. So that makes our normal reaction to become the product of the mass, which is given to be 1.6, times acceleration due to gravity, which is 10. So our normal reaction becomes 1.6 times 10. That gives us 16 Newton. So that becomes the normal reaction of the surface. Okay, so let's substitute in our equation to find the coefficient of friction. So our coefficient of friction becomes the frictional force, which is 8, divided by the normal reaction, which is 16. So 8 go here 1 time, 8 here 2 times, which is the same thing as 1 over 2. And 1 over 2, that gives us 0.5. So that is the coefficient of friction of the surface. Remember, coefficient of friction does not have any unit. So the unit will cancel out. Let's look at the second example. Calculate the magnitude of the force required to just move a 20 kg object along a horizontal surface if the coefficient of friction is 0.2, and we are given acceleration due to gravity G to be 10 meters per second square. All right, so solution. Now let's write down the parameters from the question. We are asked to calculate the magnitude of the force. So that means we are looking for what? Force that is required to just move a 20 kg object. So that 20 kg, that is telling you the mass of the object. Remember, mass is measured in kg. So the mass is given to be 20 kg and along a horizontal surface if the coefficient of friction is 0.2. So coefficient of friction, that is mu, is given to be 0.2, and we are given G to be 10 meters per second square. So how do we get the magnitude of the force? So recall that the coefficient of friction mu is equal to frictional force over the normal reaction. So since we are looking for the frictional force, we'll cross multiply. Our frictional force will be equal to mu r, product of the coefficient of friction multiplied by the normal reaction. So we are given the coefficient of friction to be 0.2, and we still don't know the normal reaction. So we need to find the normal reaction. Remember that your normal reaction is equal to the weight of the body since it's on a horizontal surface, which is equal to mass times acceleration due to gravity. So our normal reaction becomes the weight of the body, which is mass times gravity, and the mass of the body is 20 times acceleration due to gravity, which is 10. So normal reaction becomes 20 times 10. That gives us 200 Newton. So that becomes the normal reaction. So let's go and substitute to find the frictional force. So our frictional force becomes the coefficient of friction, which is 0.2, times the normal reaction, which is 200. So frictional force becomes 0.2 times 200. So I will use my calculator. 0.2 times 200. That gives me 40. So frictional force will be equal to 40 Newton. So this gives us the frictional force. Please make sure you like and subscribe to my channel for more videos like this. Bye.